Water is the most familiar substance on Earth, and the strangest. It expands when it freezes. It holds more heat than almost anything else. It has the highest surface tension of any ordinary liquid. It can climb a tree against gravity. Roughly a dozen of its properties are anomalies, behaviors no other liquid shares. All of them trace back to one thing. Each water molecule reaches out and links to its neighbors through hydrogen bonds. Those bonds form, break, and reform trillions of times a second, building a network that is constantly rearranging itself. Water is not a simple fluid. It is a structure in motion. And in nature, that structure is never forced into a straight line. A mountain stream meanders. A river coils around a bend. Water falling through air twists as it falls. Left alone, water spins. It spirals. It folds back on itself. It cools itself in the shade and gathers speed in the dark. None of that is decoration. How water moves appears to be part of how water works, how it carries, how it clears itself, how it holds a charge. And it is very nearly the only property our treatment plants ignore.
The choice was made a long time ago. In 1860, two French scientists were arguing about disease. Louis Pasteur held that specific microbes cause specific illnesses, identify the pathogen, and kill it. Antoine Béchamp held that the environment comes first, that the terrain determines whether the organism can take hold at all. Pasteur won. Medicine took his framework, and so did water. And for a while, it worked spectacularly. Chlorination is one of the great public health victories in human history. It ended waterborne epidemics in the industrial world. Nobody serious disputes that. But a victory can also become a habit. Once the answer to every water problem was a substance added to the water, the question stopped being asked any other way. An enormous industry grew up around the answer. Today, the global market for water treatment chemicals is worth roughly $40 billion a year, and it is still growing. That is not a conspiracy. It is simply what happens when a business model and a science grow up together. The tools get better every year. The premise never gets re-examined. The premise is this: water is a substance to be dosed rather than a system to be understood.
Chlorine does its work. Then it keeps going. When it meets the organic matter already present in the water, it reacts. The products of that reaction are new compounds, and there are hundreds of them. And then the water leaves. Whatever we put into water, the water carries onward. In a recent study of 22 wastewater treatment plants, per- and polyfluoroalkyl substances were higher downstream of the plant than upstream in 95% of the samples. Conventional treatment removed less than a quarter of the organofluorine passing through it. The plant was never designed to remove them. It was designed for a different century's list of problems. However we treat our water, that treatment goes back into the environment. There is no away.
So what would the other approach look like? It would begin by watching what water already does. In the 1920s, an Austrian forester named Viktor Schauberger spent his life studying the streams of the Alps. He noticed that a river left to wander kept itself cold, kept itself clean, and carried its sediment without depositing it. Straighten that river, and it warmed, silted, and went stagnant. His conclusion was blunt. The greatest damage that can be done to water is to straighten out its natural meanderings. He was not alone in that intuition. Nikola Tesla worked on resonance and on fluid devices with no moving parts. Royal Rife and John Keeley pursued the idea that matter responds to specific frequencies. Walter Russell described nature as rhythmic and periodic rather than static. None of them left a finished engineering discipline behind. What they left was a hypothesis that water responds to how it is moved and to what it is exposed to spin, to field, to frequency, to charge. In Japan, the researcher Masaru Emoto photographed water frozen slowly under a microscope and reported that the crystals it formed differed with its source and its treatment. His interpretation remains firmly outside mainstream science. But the images sent a generation of engineers back to a simpler question. And then, in a laboratory at the University of Washington, someone put instruments on the idea. Gerald Pollack, a professor of bioengineering, reported a finding in 2003 that other groups have since reproduced. Place a strongly water-attracting surface into ordinary water, and a zone forms alongside it from which particles and dissolved molecules are pushed out.
Visit www.raiseyourvoltage.us to learn more.